Follow the fish. Fisheries are responsible for a history of devastating transformations of marine ecosystems, a history of depletion and ecological destruction. Fish tell tales of how cultural and technological changes brought about both human wealth and human misery that change established logics of economy and progress. Looking at the destruction fisheries have left in their wake from an architectural perspective, it becomes obvious that the built environment of fishing provides significant evidence of ecological conflict between an extractive industry and the physiological and environmental conditions of marine species. In a history of fishing architecture that traces changes over time, we can see how construction results from the biological traits of marine species and reflects the status of oceanic ecosystems regardless of whether it is considered vernacular or modern. Following the fish, settlement patterns can be understood according to the configuration of underwater ridges, water temperature, and relative abundance of species, while the decay of certain building forms can be seen as a consequence of overexploitation and exhaustion of natural resources. Biology, technology, processing, politics, and consumption are lenses to help us perceive just how intimately entangled fish and terrestrial landscapes are. This entanglement calls for an amphibious history that relates to both land and water, and the primary goal of this book is to do just that. By drawing on work done in the growing field of socioecology, it shows how ecological factors motivate building practices and studies the impact of architecture upon the natural resources of the North Atlantic. In the long term, the hope is to establish this amphibious approach within architectural history. Among its precedents is Siegfried Gideon's chapter on slaughterhouses in Mechanization Takes Command. He brought the anonymous tradition to the forefront of architectural debate, describing the slaughterhouse as a bridge between animal husbandry and assembly line that delivered cows and hogs into the mechanical purview of modern architecture, while introducing them into the glossy pages of architectural discourse. Mechanization Takes Command describes the building processes of the assembly line and of serial production and discusses the exploitation and mechanization of nature, putting meat at the center of the architectural narrative. The slaughterhouse, as the locus for the conversion of an animal into a commodity, is examined critically by William Cronon in Nature's Metropolis, where he relates the world-famous Chicago slaughterhouses to the American landscapes that were the source of the meat they processed. We read of such things as the extinction of bison in Nebraska and Wyoming, and cowboys driving cattle north from Texas to Chicago. As in fishing architecture, the slaughterhouse and the city relate to various species and to large territories across which ecosystems are linked to urban markets. Whereas Gideon described a connection between the slaughterhouse and design practice, Cronon demonstrated its impact on the larger environment in a chapter with the ominous title Annihilating Space. In these accounts, land occupies center stage. Today, scholars are building an environmental history of architecture, tracing the sources of construction materials around the world. In these accounts, oceans are either connecting spaces across which materials move or a locus for the extraction of valuable natural resources like oil and minerals. The groundbreaking research by Nancy Cooling and Carol Hine makes the ocean an architectural topic by looking at how it is territorialized by trade routes, mineral extraction, and energy production. And, as in other recent cross-disciplinary research work on the oceans, we see arts disciplines leading the way in linking science and culture. Still, despite an awareness of the ecological impact of human actions, the links between marine life and urbanization are yet to be tackled or, in some cases, noticed. From an architectural perspective, what happens on land stays on land, and what happens in the ocean stays in the ocean. The assumption is that buildings can only be understood in the context of their direct vicinity, assessed from a human or sociological angle, and often regardless of how humans relate to other species. In that regard, fish cannot be farther away from building practices. Yet, much architecture has been built to follow fish, and it has certainly had an impact on fish populations. Considering the hypothesis of an amphibious architecture starts with fish and the marine ecosystems in which they live. The ocean has a variety of environmental factors in constant mutation, among them water salinity and temperature, currents, and the geological character of the seabed. These are accompanied by equally complex ecological conditions. The relationship between species in food chains, ranging from plankton to the higher trophic levels, vary according to predatory behavior and seasonal dynamics. And as for the fish species itself, variations in individual and social behavior, dietary preferences, spawning habits, growth rate, migration patterns, population distribution, and genetic codes all play important roles. Understanding such dynamics makes it possible to correlate architectural events with ecological episodes. As a human activity, fishing is better documented than marine ecosystems and can be inscribed within the history of technology. Fishing history combines the histories of navigation, fishing gear, and many other innovations that affected how many fish were caught. Thus, it is a useful entry point through which to begin looking at the sea-land interface. For example, how boat docks set infrastructural requirements can be a key piece of information for scholars studying the establishment of settlements, the impact of artificial harbors, and the physical relationship between fishing grounds and workforce. The scale of the vessel and the fishing effort it implies relate to capital needs and energy consumption, to the scale of the workforce, and to the related fishing output. Fishing vessels were transformed historically by the introduction of steam power, steel hulls, and diesel motors, technologies that had a major effect on catches. This changed the time and energy required to travel from the harbor of origin to the fishing grounds and back, crucial factors in the relationship between architectural output and ecological pressure. The more efficient the fishing gear and available technologies, from navigation systems and tools, fishing lines and nets, to the maps, charts, and sonar devices used to locate the prey, the more intense the pressure the fisheries exert on the ecosystem. The fishing gear used also defines the crucial moment of capture, when the balance of environment and ecosystem is actively interfered with, as well as the result of this interference. And although this equipment might seem far from architecture, larger and faster fishing landings require the building of higher capacity processing facilities. In any fishery, food processing is the pivot between natural resource and consumer product, and so processing facilities like drying racks and canneries are the most obvious architectural byproduct of fishing. An amphibious architecture history encompasses the production chain, a network of systems that starts in the boat when the fish is caught and ends when the edible merchandise is shipped to consumers. Studying the nature of each link in this chain and its repetitive mechanics provides an architectural framework through which we can assess the implications of the fishery. For instance, the introduction of freezers brought the most dramatic historical shift yet in the shape of fishing architecture, with an impact on both landscape and fish population. This is not just because the monumental presence of cold storage and freezing plants in ports and fishing villages changed the landscapes previously defined by drying racks, but also because the use of freezers at various stages in the production and consumption chains led to unprecedented increases in the distance between the ecosystem where a fish lives and where it is consumed, with a single ecosystem serving an overgrowing population. We know of the ecological impact of such transformation. Its architectural implications are part of the amphibious history tackled in this book.